Another application of orthogonal vectors is to compute a projection. So if we have some vector u, like this, and we have another vector y, it's like kind of a squiggly vector there, but we want to figure out how much of y lies parallel to u versus how much lies in some direction that's perpendicular to u. Let's call that direction z. Then we can find this projection. We can just assume that y is alpha u plus z, where z would be the orthogonal part. So we don't actually have to know what z is, we just need to know what y and u are. Then what we do is we would dot both sides of this equation with u, and we get alpha u dot u plus z dot u. And since z is assumed to be the part that's perpendicular to u, then this dot product is going to be 0. So we can solve for alpha. We'll find that alpha is equal to y dot u divided by u dot u. So, okay, then we'd know. Then we would be able to find z as well, because we know y and now we know alpha. So z would be y minus whatever alpha is times u. So we call this alpha, we would call the component of y in the direction of u. It gives us a kind of a plus or minus length of the shadow that y would cast perpendicularly down onto u. So, and then alpha u we would call the projection of y onto u. So the difference is alpha is just a scalar, alpha u is a vector. Let's do an example here. So we want to write y here as something that's in span u. So in other words, write y as a scalar multiple of u plus a vector that's orthogonal to u. So we figured out that you could calculate this alpha. So what we're thinking of is that y would be equal to alpha u plus some vector z, and we can find alpha by finding y dot u over u dot u, which in this case y dot u is going to be 8 minus 21, and u dot u is going to be 16 plus 49. So 8 minus 21 would be negative 13, and 49 plus 16 would be 65, and 13 goes into 65 5 times, so we find that alpha is negative 1/5. So the projection of y onto u is going to be equal to negative 1/5 of u. So that's going to be negative 4/5, and negative 1/5 of negative 7 would be positive 7/5. So then we could find this amount z as well. So this projection is also what we're calling alpha u. We could also find that vector z, because z would be y, that's 2, 3. Take away alpha u, so minus negative 4/5, 7/5. So 2, that's 10/5, minus 4/5 would be 14/5. And 3 is 15/5, take away 7/5 would be 8/5. We can check our work here, because this vector z should end up being perpendicular to u. So if we check z dot u, let's see what we get. We get 4 times 14 over 5, so that's going to be 56 over 5, minus 7 times 8/5 when we do multiply the second components. 7 times 8 is 56, so that's going to be negative 56 over 5. So yeah, z turned out to be perpendicular to u, so we must have calculated the projection of y onto u correctly, because what was left over was actually perpendicular to z.